Hello again everyone, welcome back to ptet.chemistry channel. So this is the first work 1. There's for the Combined Science 5129 formula and equations topic. So you should probably have mastered all the common formula of cations and the anions. This include the polyatomic ions, which are not given at all, which you can't work out from the periodic table at all, so be very careful about those before you even get started with these. As usual, you should really know the 3 common acids, the hydrochloric acid, which will give you the chloride salt, and then you have sulfuric acid, H2SO4, which will give you sulfate salt, sulfate which is SO4 2 minus. Then you have HNO3, which is nitric acid, which will give you nitrate. So each of these, chloride, sulfate, and nitrate. So Cl minus is called chloride, SO4 2 minus is called sulfate, NO3 minus is called nitrate. So these come from the acid. Of course, then you also have some other one, which is OH minus. This is not acid, this is a base, it's alkaline. You call it base or alkaline. Metal hydroxide, all are basic or alkaline. You also have another polyatomic ions, it's called ammonium NH4+. The plus there represent +1. So this is ammonium ion. It is not ammonia molecule, which is from your covalent topic. Be very careful about these things. Yeah. Let's get started. We have sodium sulfate. There's a new spelling for sulfate now. You might want to change this to the new spelling, SULFATE. So what we have is Na plus SO4 2 minus. The charge of this ion is the valency. The valency is the combining power based on the charges of this ion, so it's just 1. Just bring down the value. Then you cross multiply the value of this valency. The value 1 from the left goes to the right, the 2 goes to the left. What does this number represent now? We haven't changed this at all. We have this number now just mean there are 2 Na plus, so it's Na plus and Na plus, and there is 1 SO4 2 minus. What it means is the charges now get cancelled out. +1 and +1 give you a total of +2. Cancel out the -2. The overall compound, which is sodium sulfate, which is an ionic compound containing cations, positively charged ion, and also anion, which is negatively charged ions, will have no overall charge. That's why you write it down as Na2 because there's 1 and 2 of it. So you read from left to right, there's 2 Na and 1 of the SO4. I don't need a bracket because it's just 1 unit of it. So it's Na2SO4 sodium sulfate. Next one, copper 2 carbonate. This is the valency of the copper. It means it's Cu2 plus because the valency in Roman numeral represents the charges of the metal ion itself where relevant. Carbonate, I haven't mentioned this yet just now. Perhaps I should also mention the carbonate is CO3 2 minus. So I will just very quickly move this up a little bit. Then I have a bit more space to write it down somewhere. CO3 2 minus is carbonate. So these are some of the more tricky one, I guess. Carbonate, chloride, sulfate, nitrate, and hydroxide. So CO3 means 1 carbon, 3 oxygen, but this is ion, it's got a 2 minus charge. CO2 is a molecule, carbon dioxide. You are breathing out carbon dioxide. There is a molecule, this is an ion. Ion is charged based on your atomic structure topic back a couple of months ago. The valency is the charge of the ion, so the 2 plus mean the valency is 2. The 2 minus mean the valency is 2 also. You cross multiply the numbers, the valency, so 2 and 2, but you don't write Cu2, CO3 twice because these are not the simplest whole number ratio. So what you do is you do divided by 2 because you can simplify it further. So now that you have got the simplest whole number ratio, simplest whole number is something you will have done in primary school mathematics. What this means is 1 of the copper 2 plus and 1 of the CO3 2 minus. So that means the formula is just 1 copper and 1 CO3 2 minus. I don't need a bracket because it's just 1 unit of it. Moving on, so I have magnesium nitrate. So I'm slowly running out of space here, but I'll try and work within the space given. Nitrate is NO3 minus. Remember, these are never given in exam. You got to know the formulas from the name itself. Magnesium is a group 2 metal that form a +2 ion because they want to complete the outer shell. Now you have 2 for the valency and 1 for the valency of nitrate. You cross multiply them. So this is magnesium nitrate. 2 goes on the right, 1 goes on the left. What this means is 1 Mg2 plus. What this means is NO3 minus and NO3 minus. So you got 1 of these, and you got 2 of that. So ultimately you have 1 magnesium. But now I have to use bracket because I want to show that I have 2 of this whole thing, whereas previously I only have 1 of this whole thing and 1 of this whole thing. Now I have 2 of this whole thing. It means 2 nitrogen. It means 3 times 2, which is 6 oxygen. 3 plus 3 is 6 oxygen. 3 times 2 is 6 oxygen. 1 times 2 is 2 nitrogen. 1 plus 1 is 2 nitrogen there. Okay, moving to the next one, ammonium sulfate. So I'm slowly running out of space on everything, but anyway, this is D. Ammonium is NH4 plus. As I said, ammonium is not ammonia. Be very careful. Gotta know the number of atoms, gotta know the charge as well. Ammonium sulfate, SO4 2 minus for the sulfate. Valency, based on the charges. If you know these, no one can trick you because the cross multiply is the easy bit. Knowing these are the most difficult thing of all. So make sure that whatever you do learn these things. 2 goes on the left, 1 goes on the right. What the number represent is how many of these do you have? You have 2 ammonium, you have 1 sulfate. So what I can write is, based on that, 2 ammonium. So I will use a bracket NH4. I no longer need to write down the charge, but I need to show I have 2 of it. 2 of these, 1 of it, 2 of it. And then I have sulfate. The sulfate is just 1 unit, so I don't need a bracket 1. It's just 1 unit, just like the previous question. I don't need a bracket 1 because I only have 1 sulfate after I did a cross multiply. Plus 1 and plus 1 give me plus 2. Cancel out the minus 2. Ionic compound or any compound at all do not have any charge. Hydrochloric acid, very straightforward, HCl. You can imagine it as a combination of H plus and Cl minus. You can do the same thing and you get HCl as well. Aluminum carbonate, let me change the color. Aluminum carbonate, so this is F. Aluminum, Al3 plus, carbonate, CO3 2 minus. You should practice this at some point without looking at your notes or my solutions. So the valency follow the charges. 2 and 3 swap places. What this means is Al3 plus, Al3 plus. What this means is CO3 2 minus, CO3 2 minus, and another CO3 2 minus. So 2 of these and 3 of that, meaning I can write down 2 of aluminum, and then I need to use a bracket to show 3 of the carbonate. Magnesium chloride, so I have Mg2 plus and Cl minus, 2 and 1 following the charges, but don't forget you must cross multiply before you get the final formula. So this means 1 Mg2 plus and this means 2 Cl minus, because this Cl minus there are 2 of them. Minus 1 give you minus 2, cancel out the plus 2 charge, 1 magnesium, 2 Cl minus. Next one, potassium nitrate, K plus and NO3 minus, 1 and 1. So whenever things are 1 and 1, very simple, you just have 1 of each. So it's KNO3. I do not need a bracket because it's just 1 unit of it. Silver nitrate, Ag plus for the silver, NO3 minus for the nitrate. Again, the valency is 1 and 1. So life is pretty simple when it's 1 and 1. It means 1 Ag plus and 1 NO3 minus, so it's just AgNO3 for the silver nitrate. On to the next one, zinc hydroxide, which is a bit more tricky, but zinc, when they form ion, is Zn2 plus, stated in your valency table, which are not given in exam, by the way. Hydroxide is OH minus. The minus refer to the whole thing, OH minus. Valency follow the charges. Cross multiply the valency. 1 goes to the left, 2 goes to the right. Now this represents how many of these things on the left. You have Zn2 plus, 1 of it. You have OH minus. You have 2 of the OH minus, 1 and 2, because this is how many of these. So I will have Zn and then bracket OH twice because I have 2 of these OH minus. Iron 3 chloride, the valency refers to Fe3 plus, and I have Cl minus. The valency is the charges on the ion, so just look at the number, which is 1, the number, which is 3, cross multiply them, then you get 1 on the left and 3 on the right. This represents 1 Fe3 plus, the 3 represent 3 Cl minus, such that I get FeCl3. FeCl3, better write that properly. Let me change the color of my ink. Iron 2 nitrate. I'm slowly running out of space here. This is part L. Iron 2 nitrate. Iron 2 nitrate. Iron 2 is not iron 3, so it's Fe2 plus, NO3 minus. Plus 2, oops, sorry. Valency is just the number, so 2 and 1. Nitrate is NO3 minus. Don't forget, you must cross multiply before you get the correct formula. So 2 goes on the right, 1 goes on the left. This means 1 Fe2 plus. This means NO3 minus, NO3 minus, 1 of it and 2 of it. Because it's iron 2 nitrate, I will have Fe, NO3, 2 of them, because based on the cross multiply there. Next up, I have nitrite with the IDE. IDE there refer to N3 minus, where the nitrogen atom gains 3 electrons to get to a fully filled, completely outer shell. Okay, fully filled outer shell there. So part M there, I have Mg2 plus, I have N3 minus. So 2 and 3, these are the valency based on the charges of the ions. So make sure you can identify the ions from the name. So the cross multiply means 2 goes there, 3 goes there. These are the simplest whole number ratio. So again, what it means is how many of it do you have? Well, I have that, and I have 2 of the N3 minus. Plus 2 plus 2 plus 2 give me plus 6. Minus 3 give me minus 6. The idea is cancel out the charges so that my compound has no charge at all. I have 3 magnesium. Perhaps I can write it better. I have 3 magnesium and 2 nitrogen, Mg3N2 there. Next up, I have ammonium phosphate. Okay, you might not have learned phosphate in your table, but phosphate is PO4 minus. Actually, phosphate is in that valency table that was given in your notes, so you should have learned it before. So NH4 plus and PO4 minus. Should probably move that a little bit there so that I'm using all the space given there. So 1 and 3 following the charges on the ions, there's the valency. Then cross multiply the valency. 1 on the left goes to the right, 3 on the right goes to the left. This means I have NH4 plus 3 times like this. Probably don't have to write it every single time, but I'm writing it out so that you can see what is going on. So there are 3, 1, 2, and 3 of these, and 1 of that. I do not need a bracket if there is 1 of it. Finally, part O, I have iron 3 hydroxide. Iron 3 hydroxide, I have Fe3 plus and OH minus, 3 and 1 because of the charges which represent the valency. So 1 goes there and 3 goes there. So without writing it out now, you can see there are 3 of these OH minus. Actually, I'll probably write it down so that, so that you can see very clearly. 1, 2, and 3, and I've got 1 of the Fe3 plus. So Fe OH 3 times. Okay, so I hope that is clear so far. There's not much point of doing it again and again if you're not very familiar with all the formula of ions. So make sure whatever you do, you go back and you master this thing, because once you master the most common things, you can do thousands and thousands of different examples. Okay, so what do we have here is we need to name the following compounds. Just now, we are given the name and we convert them to the formula. Now from the formula, we must convert them back to the name. So it's very tempting to see that there's 2 of these iron. It's very tempting to say it's iron 2, but it's actually wrong, because remember, there are no overall charge. Compound has no overall charge. So you must work backward. What you have done previously, so you've gotten the final result. Now you have to work backward and find out what is the valency and therefore what is the charges of the ion. Because for example, this thing, if I work backward, Fe2O3 means I have got 2 Fe, I have got 3 oxygen. The oxygen there is 2 minus, So that is 3 times minus 2 is minus 6. Therefore, I must have plus 6. I have 2 of these. Both of them add up to plus 6 because they will cancel out the minus 6 since the compound is no charge. Plus 6 divided by 2, that means I must have 3 plus. If I have plus 3, guess what? If I have plus 3, that means it is what you pronounce as iron 3, because previously, because you have done this work yourself, you know iron 2 is going to be Fe2 plus. Iron 3 is going to be Fe3 plus. So there is a difference in the name based on the valency in this Roman numeral included in the name. You cannot just call this iron oxide, you will be wrong. It's iron 3 oxide because it has to be iron 3 plus in order for the valency like that to cross multiply and give you this final result of Fe2O3. So the name, the correct name is iron 3 oxide. Be very, very careful there. On to the next one. We know the NO3 unit is NO3 minus. NO3 minus is what you call nitrate. So how many nitrate do you have? You have 2 nitrates. So you have NO3 minus and NO3 minus nitrate. So altogether, you have minus 2 charges. Total minus 2 from the anion. So what happened to the cation is, the cation, you only have 1 of it. Therefore, you must be Pb2 plus. Pb2 plus, the plus 2, 1 of it, cancel out the minus 2. Overall compound has no charge. Pb is lead. Lead can be lead 2 or lead 4 as stated in your notes under this bit where some of them can have different charges, therefore different Roman numerals to represent the valency of that particular species. So this is called lead 2 nitrate, sorry. You pronounce it as lead instead of lead, okay? I don't know, actually, I'm not an English teacher, so, you know, probably best if you ask an English teacher. OH minus is hydroxide. OH minus is hydroxide. So what you have then is you have 2 of them. So if you have 2 OH minus, you have 2 OH minus. Overall is minus 2 charge. So therefore it means you must have, excuse me, it means you must have calcium 2 plus. But calcium you do not need to put in Roman numeral because calcium is a group 2 metal. Group 2 automatically will be a plus 2 charge ion. So this is called calcium hydroxide. Next up, silver. Silver ion, Ag plus, Cl minus is a chloride. This is called silver chloride. It's not chlorine because it's a Cl minus. One of the biggest mistakes that a lot of students make is they don't know how to spell chloride and they don't know what is chlorine because they don't know what is going on in the first place. Next up, we have an ionic compound, metal and non-metal. Metal and non-metal. The metal metal loses electron. I beg your pardon. What am I talking about? There are 2 Na plus and there is 1 time O2 minus. This is actually sodium oxide, and you can relate back to dot and cross diagram for the ions that you will get as part of ionic bonding. This is a sulfate. SO42 minus is a sulfate. You only have 1 of it, that's why they don't have a bracket. Because this is minus 2 and you only have 1 of the metals, therefore it's copper 2 plus. Copper is in one of those metal in the middle block of the periodic table. That's why we need to put in a bracket to represent the charges or the valency, because this number represents the valency of the metal, which is going to be positive because, you know, metal loses electrons to give you cations or positive ions. It's copper 2 sulfate. Next up, we have K2CO3. Hopefully you can remember CO3 2 minus. CO3 2 minus is an ion. It's called carbonate. And of course you have 2 minus. That's why you need 2 of the K plus. 2 of the K plus mean K plus and K plus. Potassium is group 1 metal. That's why they form a plus 1 charge. A valency of 1 because they are group 1 metal. They lose 1 outer shell electrons. But because to cancel out minus 2, I need 2 of them. Plus 1 and plus 1 give me plus 2 total. Cancel out minus 2 charge from 1 carbonate, so that the overall compound has no charge. That has always been the objective, to get the overall compound being no charge. Again, you have CO3 2 minus carbonate. And here you have 2 times NH4 plus. NH4 plus has a name of ammonium, so this is ammonium carbonate. Next one up, K plus and I minus, identifying. You got to learn to identify your cations and your anions. Not everything is cation and anion, so you need to be very careful and know about your tables of ions, as well as you should also be on the lookout for covalent compound, simple covalent compound like HCl, H2O, CH4, NH3, CO2. These are all covalent molecules, and they are all stated in the syllabus from bonding. They are also what they expect you to do at the beginning of this topic. Candidates should be able to state the formula of elements as well as compounds stated in the syllabus. Hydrogen chloride, or sometimes they call it hydrochloric acid when you dissolve hydrogen chloride in water. This is water, H2O. CH4 is methane, methane. NH3 is ammonia. CO2 is carbon dioxide. These are molecules that have got nothing to do with ions at all. This is a metal and non-metal. This is a group 2 metal, Mg2 plus, the valency is 2. This is a group 7. This is F minus, so they will gain 1 electrons to get to completely fill out the shell. This is what you call magnesium fluoride. It's not fluorine because this is F minus and not F2 molecule and not F atom. Okay, so that's it for these tutorials where we have covered a little bit of how to get the formula of the compound from the name, as well as how to get the name from the formula itself. Alright, thank you for watching. Make sure you click the button on the bottom right to subscribe to the channel, and follow me at ptet.chemistry on Facebook, Instagram, and Twitter to get connected and send messages. And yeah, please share the channel widely with everyone else you know who can benefit from this tutorial. Thank you for watching.